In this video, I will show you how to multiply a matrix times another matrix. But first, we have to make sure that the matrix multiplication is even possible. So the dimensions of the first matrix are 2 by 3, 2 rows and 3 columns. The dimensions of the second matrix are 3 by 2 because we have 3 rows and 2 columns. For matrix multiplication to be possible, the inner dimensions have to be the same. These are the same, so this will be possible. The outer dimensions tell us the dimensions of the final answer. So our final answer will be a 2 by 2 matrix. And in fact, we should go ahead and make a very large 2 by 2 matrix right now. So here's my setup for a really big 2 by 2 matrix, enough to fit all of our work. We will grab the rows from the first matrix, and we will grab the columns from the second matrix. Let's start with the rows. Row 1 will go across row 1. So even though this is a row, I'm going to write it vertically by writing 4, 6, I am not saying the same numbers I'm writing down. 5, 4, negative 6. 5, 4, negative 6. Now row 2 goes across row 2. Negative 6, negative 2, negative 1. Now let's do the columns. Column 1 will go down column 1. 5, 0, negative 5. Column 2 will go down column 2. Negative 2, 6, negative 2. Next, we multiply these pairs. So we'll get 25 and 0, 30, negative 10, 24, 12, negative 30, 0, 5, 12, negative 12, and 2. Finally, we add the green numbers up, and that will lead us to the final answer. So this is going to be 55. And let's see, so that's 36, 26. All right, and this is going to be negative 25. And 2. Okay, so the final answer is the 2 by 2 matrix 55, 26, negative 25, 2. Let's practice that again. Again, we have to first check to make sure that the matrix multiplication is even possible. So the dimensions of the first matrix are 2 by 3, 2 rows, 3 columns. The dimensions of the second matrix are 3 by 2. All right, so this is very similar to the one we just did. The inner dimensions have to be the same, and they are, so this is going to be possible. The outer dimensions tell you the dimensions of your final answer. So again, our final answer will be a 2 by 2 matrix. And we use that information right now to set up a large 2x2 matrix in which we will do our work. We steal the rows from the first matrix and the columns from the second matrix. Row 1 goes across row 1. 5, 2, -1. Row 2 goes across row 2. Now let's do the columns. Column 1 goes down column 1. Column 2 goes down column 2. Next, we multiply. And I always have to just pray that I don't make a careless mistake. This is so mind-numbing that it's very easy to just make a careless little mistake. But I'm sure you'll shout out and warn me if I make a mistake, won't you? It becomes a pain to go back and try to edit these videos. Usually, I'll just make a pop-up card. Say, oops, that should have been -12. But hopefully that won't happen on this video. All right, finally, we add up the green numbers. So this is going to be -40 and -8 and 18 and 6. So that's why the final answer is going to be -40, -8, 18, and 6. So this is the 2x2 matrix that we were promised would be our final answer, would be a 2x2 matrix. So there it is. So let's do another example. Is this matrix multiplication going to be possible? The dimensions of the first matrix are 2x4. The dimensions of the second matrix are 4x2. 4 rows, 2 columns. For matrix multiplication to be possible, the inner dimensions have to be the same. These are the same, so this will be possible. The outer dimensions tell you the dimensions of your final answer. So our final answer will be a 2x2 matrix. Let's use that information to go ahead and create a large 2x2 matrix right now. We will grab the rows from the first matrix, and we will grab the columns from the second matrix. But let's start with the rows. So row 1 will go across row 1. So we will have 4, -1, 6, -1. row 2 will go across row 2. So -3, 6, -2, -4. All right, now let's do the columns. Column 1 will go down column 1. So we will have 3, 3, -4, 5. Column 2 will go down column 2. So that's going to be 2, 4, 0, -6. Next, we multiply each of these pairs together. Oops. And finally, we need to add up all of these numbers, and that will give us the final answer. So these are the answers you get if you add up all of these numbers. So that's why the final answer is going to be the matrix -20, 10, -3, and 42. Number 15, will this matrix multiplication be possible? Well, the dimensions of the first matrix are 2 by 2, and the dimensions of the second matrix are 2 by 4. 2 rows, 4 columns. In order for matrix multiplication to be possible, the inner dimensions have to be the same. In this case, the inner dimensions are the same, so this is going to be possible. The outer dimensions tell you the dimensions of your final answer. So our final answer will be a 2 by 4 matrix. So let's use that information to make a rather large 2 by 4 matrix like this. All right, so now we are all set up with space for a large 2 by 4 matrix. So we're going to take the rows from the first matrix, and we will take the columns from the second matrix. So row 1 will go across row 1. So we will have 6, -2, all the way across. Row 2 will go across row 2. So we will have 0, -2. Now for the columns. Column 1 will go down column 1. Column 2 will go down column 2. Column 3 will go down column 3. And column 4 will go down column 4. All right, next it's time to multiply all of these together like this. Okay, I did not leave myself quite enough space, so I'm going to have to really squeeze this in. All right, this is why we have to make this matrix so large, so there's room for these calculations. So I could have made it a little bit bigger. All right, finally we need to add up each of these pairs of numbers. And this will lead us to the final answer. Okay, so we're going to get negative 24. And here we're going to get negative 28 and negative 20. And 24. And 12. And 8. 10. 6. But don't leave it like that. Go ahead and write your final answer as a separate matrix. So here's the final answer right here.